Alright, hello Algebra 1 students. Today we're looking in our Unit 2 note packet at notes 2-3. 2-3. We're going to be talking about functions and whether things are functions or not a function. Okay, so the first thing I want you to do is write this down. A function is a special relationship values where each input x has exactly one output y. And that statement right there is just a fancy way to say that the x's cannot repeat. So if you have ordered pairs or tables or a map of different points, what you're looking for is the x values cannot repeat. So for instance, if I have a set of ordered pairs like 0, 3, 1, 3, and 2, 3. This is a set of ordered pairs. What you're looking for is the x values not to repeat. So you're looking at 0, 1, and 2. Those do not repeat, so we're good to go. But now, say for instance, if I had a set of ordered pairs that were like 3, 0, 3, 1, 3, 2. You see how those threes, they repeat? So this means not a function. Okay, and that's the difference there. So let's go ahead and look at these examples. So when you have ordered pairs, it's fairly simple. You're looking at the first number in each set of parentheses. So I have a 5, I have a 3, I have a 2, a 0, and a -1. None of those repeat. None of those repeat, so this is a function, and you could put yes or you could put function. I'm going to go ahead and put yeah, it is a function. Yeah, it's a function. All right, number 2, we're looking at only the x values, so -2, 0, 2, 3, and 2. Uh-oh, this 2 repeats, so no way, Jose, not a function. All right, now looking at 3, we have -4, we have -3, -2, 1, and uh-oh, those -3s, they repeat, so this is not a function. Nope, way, nope. Okay, so now looking at 4, I have a 1, I have a 2, I have a 3, I have a 4, and a 5, so those do not repeat, so yep, this is a function. Okay, notice how I'm only looking at the x values. I don't even care about the y values. You only look at the x. Now, when you have a table, I think for me the table is the easiest to see it because it just makes the information so organized. So you're only looking at the x column and you're looking to make sure that none of the x's repeat. So 3, -1, 0, 2, uh-oh, these 3's repeat, so this one is not a function. All right, now we can look at 6. I'm looking at -4, and I always try to circle what makes it not a function just so I can keep myself organized. So -4, -2, 1, a +2 and a -2, those are different numbers. So as long as one of those has a negative sign, we can go ahead and call this a function. So yes, this is a function. All right, now looking at number 7, I have -5, -3, 0, 1, 2. Yes, a function. Remember, notice how I'm only looking again at that x column. Those y's, they can repeat as much as they want, but we can only have one x value. All right, so looking at number 8, I have a 1, a 4, a -7, and I have a 4 again. So because these 4's are the same number, it means they repeat. This is not a function. All right, number 9, I have -8, -4, 0, 4, and 8. Now, some people might get confused by this 4 and this 8 and this -8 and -4, but negative numbers are not the same as positive numbers. So this actually is a function. And other people may get confused by the y column. But remember, you only have to look at the x's. You do not care about the y's when you're deciding whether something is a function or not. All right, looking at number 10. 1, 2, 3, 4, 5. Okay, so this is a function as well. Yes, it is. Awesome. So now what we're going to do, the map here. Now, I noticed on our last notes, maybe some of us were still confused about this. So what this map is saying is that -3 is a pair with 0. So if I were to write these ordered pairs out, it would be -3, 0. And you don't have to do this. I'm doing this just one time to show you what this actually is telling you. So then it goes to -1 to 4. So we have -1 and 4. And then 2 points to 7. So we have 2, 7. And then 4 also goes with the y value of 4. So if you were to look here, you're looking at -3, -1, 2, and 4. Those don't repeat, so this is a function. Okay? So now I'm going to show you how to just look at it without pulling out your ordered pairs. So when you're looking at this, you're only looking at this circle here. You don't care about the y circle. So 4 goes to 1, y, but -1, do you see how it has this little point here? This is a problem. That means we have the point -1, -1, and -1, 7. That means that x value is going to repeat. So anytime you have that little point in the x circle only, this means that this is not a function. So no, not a function. All right, and then 13 we're looking at the x circle only. I don't see any points over here, so yes, this is a function. All right, let's go ahead and turn to the back now. Okay, so on the back, now we're going to decide whether graphs are function or not. And we're going to use something called the vertical line test. For short, I like to call it the vert line test. Okay, it is, so what the vertical line test states is that if a vertical line intersects a graph more than once, then it's not a function. So here, I'm going to go ahead and draw a graph here. Here's my graph. A function could be something like, let's see, like a parabola, so something like this. Okay, so if we were to take a vertical line, it's not going to hit that function more than once ever, okay? But something that's not a function would be like a circle, okay? Because let me draw a vertical line on these. So this vertical line, here it is only hitting at one point. But right here on the circle, look, I draw a vertical line and it hits here and here. Uh-oh, that means it's not a function. So let's do the vertical line test on these examples. So number 14, I'm going to start from the left to the right. I'm just going to move my pencil or my marker here. Uh-oh, do you see right here at this vertical line, it's going to intersect twice? So this would make this not a function. So no, it's not a function. All right, 15, I'm doing the vertical line test. It hits at this point just once. Moving over, it's hitting this point right here just once. Moving over, it's hitting this point on the axis just once. Moving over, just once, just once. So this one would be a function, yes. All right, now let's look at this line here. I'm going to take my pencil to use it as a vertical line test, and I'm going to take it from the left to the right. It's only hitting this vertical line at one point as I move it. It's never going to hit it twice, so this is a function. All right, now let's look at number 17. Number 17, I'm taking it from the left to the right, and right away I notice it hits it here and here, so this is not a function. No, not a function. 18, I have a circle. Oh, I drew a circle already in the examples. Uh-oh. So anyway, we'll try it again. We'll take the vertical line. Oh, it's going to hit here and here. Uh-oh, this is a problem. So this is not a function. If it hits your vertical line more than once, it's not a function. So on 19, I'm taking my vertical line, I'm going across, 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 still only hitting one point everywhere I go across. So this is a function. All right. So now looking at 20. Now 20, the vertical line test, if I put my vertical line on their vertical line, this vertical line is going to hit at every single point. It's infinite number of points. And if it hits more than once, it's not okay. So it hitting infinite number of times means it's not okay and it's not a function. So this would be nope, not a function. Sorry, dude, but you're not a function. All right, so now we're looking at 21. Taking our pencil and we're going from the left to the right. I'm looking at only hitting once. Oh, I'm seeing maybe where it's going to hit twice, but as I keep going, it's only hitting one time here. There's not another time. So I keep going, ooh, one time, still just one time. So this one is a function. Yes, it is. Yeah, it's a function. All right, that's all that we have for your notes today. Make sure that you're asking for help if you get confused on any parts of these, and make sure you're getting your work done.